In this video, I'm going to look at modeling this sort of closed conduit shape in subsurface utilities. So the shape is shown by the yellow, green and red graphic. So it's basically part of a circle, but with a bench and a low flow channel. And what I want to do is model this shape accurately so that the 3D model is correct. So what I did to start with was I drew this shape in MicroStation, so the yellow, green and red graphical elements, and then I placed some grey lines, and then I looked at the properties of the lines to get the length. So knowing the position of each of these lines from the base of the channel, so the distance from the base of the low flow channel up, and then the length of each line, I can build up a table of heights and widths that describe a series of points around the perimeter of this shape. The next step is to use that table of heights and widths to create the shape that I need. In the Subsurface Utilities ribbon on the Components tab, I'm going to go to Prototypes. I've already created this, so I've created under Conduit, I've created a new prototype and I've given it a suitable name. Let's look at the right click and look at the properties of that prototype. And see how I've set it up. So scrolling down through, the first thing is that I've said that the conduit type is a user-defined conduit. So I'm going to define the shape of it. I'm not going to read it from a catalogue. The next thing is the section type, and here's a list of all the different section types that the software supports. So I've said that this section is going to be an irregular closed section. I've then picked a material for it, so there's a drop-down list of materials, and then here's where we use that table. So we specify a depth width curve, and if I click and browse to see that table, here's the values that I measured using a MicroStation. So at a relative elevation, so an elevation up from the bottom of that shape of 0, the width is 0. And then you can see that we've got a series of elevations, relative elevations from the bottom of the channel and the width. So that low flow channel is 150 millimeters in diameter. So halfway up the channel is 75 millimeters. So at that height, the width is 0.15 meters. At the next height increment, I've put in the width as 1 meter. So just going back to the picture that I showed you earlier, that table is the height coming up from the bottom and the width of each line. So that red arc there is 150 millimeter diameter pipe, so halfway up it is 75 mil. So at a depth of 75 mil, the width is 150 mil. Then the next line up in the table, because these green lines are straights, I don't need to put points along a straight line. I need the point at the end of the straight line here, so that's at a height increment of 0.1 and the width at that point is 1 meter. So come back to the table, there's the height increment of 0.1 and the width of 1, and so on. We work our way up the heights until we get to a width of 0 again at the very bottom of the conduit. So if I just arrange those two side by side, hopefully you can see the correlation between these relative elevations coming up from the bottom of this channel and the widths measured horizontally across the channel. So having set up the depth width curve table, I can close that dialog, and then the final property we need to consider is the thickness of the wall. So I've put in a value here. So those are the 5 properties in the prototype that I need to set up to model our pipe shape. So the next thing to do is to set up a feature definition that we can use to call the prototype. So in Explorer, under feature definitions, now I'm working in the active design file here. Maybe it's a project specific existing conduit shape that we need to model. If it was a shape that I was going to want to use on multiple projects, then I would be better to set this up in a DGN library. But I've got a feature definition here for stormwater concrete, which I'm just going to right click and copy. And let's rename this just to give it a sensible name. Having done that, we'll right click and go to properties. So these are the properties of that feature definition. Now this one includes a trench template, which I don't need, so I'm just going to select that row of text and delete it. And here's the property for the prototype. So I need to select the prototype that I've just set up. So there it is, and I can pick it. So that's the feature definition set up. So having set up the feature definition, the final stage is to use it and see how it looks. So we go to the layout ribbon and place conduit. We can pick the feature definition from our dialog. So arch with low flow channel, we can select that. Notice the dialog says that it's a user defined conduit. Now I've already got 2 nodes, 2 stormwater nodes that I've placed in the design file, and you can see that as I've selected the start node, there's a graphic being drawn which is trying to represent the shape of that arch conduit. So let's pick the stop node, and we can now see in the 3D model the shape of our conduit. Now let's have a look at it in cross-section just to prove that we've got the shape we want. So from the Utilities View ribbon, I can go to Open Cross-Section Model. I'm being prompted to locate the corridor alignment, so we'll pick the conduit. And I'm just going to specify a couple of left and right offsets. We will start at the start of the conduit, and we'll maybe see a section every 5 meters. So I'll click to accept those prompts, and then finally I'll open a view and click to accept it. So now we're seeing the cross section at chainage 0, so we're actually seeing a slice through the end of the node, and also we're just seeing the very start of the conduit there. So if I step forward, we can see here the shape of the conduit that we're modeling. And the advantage of setting up this shape in the prototype is that we can model this conduit hydraulically. We can calculate the wetted perimeter, for example, from that table of depth width curves, and we can get the hydraulic analysis of this conduit correct.